Problem number 25 asks for us to write the equation of the line that has a slope of 1/2 and passes through the point -4, 5. So this is another great example of our y equals mx plus b form, where we already know the slope or the m value is 1/2, and we're going to utilize this ordered pair -4, 5 to find our b value. So our y value is 5 equals our m value of 1/2 times our x value of -4 plus b, because that's what we're looking for. -4 times 1/2 is -2 plus b, which equals 5. So we'll add 2 to both sides. 5 plus 2 is 7 equals b. So again, I know the slope. I know the y-intercept. We can write an equation in slope-intercept form. Y equals 1/2 x plus 7. Problem number 26. Write the equation of a line that has a slope of -3 and passes through the point 5, -2. Again, we know the slope, and we're given an ordered pair. So we're going to start with y equals mx plus b, where my m value will be -3. My y value is -2. My x value is 5 plus b. -3 times 5 is -15. We will add 15 to both sides to isolate my variable b and get it by itself. -2 plus 15 is 13 equals b. So we now know the value of b. We know the value of our slope. So our equation, y equals -3x plus 13. Number 27, write the equation of a line that is perpendicular to y equals 3x minus 14 and passes through the point -9, 4. Well, the first thing we're going to do is look at this equation, y equals 3x minus 14. We want a line that's perpendicular to it, which means we're going to have an opposite reciprocal slope. Our current slope being 3, our new slope being the reciprocal 1/3, and its opposite negative. So our new slope is going to be -1/3. Then the process is identical to everything we've been doing in the previous two problems. We utilize our new slope of -1/3 and our ordered pair, y equals mx plus b, where my y value is 4 equals my slope -1/3 times my new x value of -9, plus b. -1/3 times -9 is +3. We subtract 3 from both sides, and b will be equal to 1. Well, we again know the y-intercept and our new slope. So our new equation is going to be y equals -1/3 x plus 1. Number 28, what is the slope formula? M equals y2 minus y1 over x2 minus x1. What's the difference between slope-intercept form and standard form? Well, slope-intercept form is y equals mx plus b, where the m is my slope, the b is my y-intercept, and the x is any input with y being any output. Standard form is ax plus by equals c, where a represents any coefficient, b represents any coefficient, and c represents any constant. And the advantage to these is when a problem is in standard form, we can plug in a 0 for either x or y to solve for the other variable. What is point-slope form? Point-slope form is y minus y1 is equal to m times x minus x1. Where my y and x we will never touch or replace. Our y1 is going to be a value from an ordered pair. My x1 is going to be a value from an ordered pair. And my m is going to be the given slope. Identify which equations form the same line. Now, the equations that form the same line are going to be the ones that simplify to the same slope-intercept form. So in order to determine which ones are the same, we're going to write them all in slope-intercept form and see which equations match each other. So here I will add 5 to both sides, and we'll be left with y equals 2x plus 5. Well, that one definitely matches. Problem C. In order to isolate the variable, we're going to add 5 halves to both sides. So 1 half y is equal to x plus 5 halves. We still need to isolate the variable, so we're going to multiply by 2 to both sides. And that's going to leave us with y equals 2 times x, which is 2x. 2 times 5 halves, well, my 2's will simplify out and leave us with plus 5. Again, we have an equation that matches. Problem D, y plus 5 is equal to 2x, so we'll subtract 5 from both sides. Y equals 2x minus 5. Well, the intercept positive 5 and the intercept negative 5 are two different intercepts, so that will not give us the same line. Problem number E. I'm going to go ahead and remind you about how to clear fractions. We can clear fractions on any given equation by multiplying by a greatest common factor. So if I multiply each one of these terms by 10, 10 times 1/10 is simply 1, so that's going to leave us with y, plus 10 times 1/5 is 2, equals 10 times 1/2 is 5. That makes this problem now a little bit easier for us to work with. We need to subtract 2x from both sides, and we end up with y equals negative 2x plus 5. This gives us an opposite slope, so it also will not be the same line. Letter F, we will add 8x to both sides. So 4y equals 8x plus 20. And then we're going to divide both sides by 4. So y will be equal to 8 over 4, which is 2x, 20 over 4, which is 5. Well, that one does match. G, y equals 5x plus 2. Well, those two have completely different slopes, so we don't have to do anything but recognize slopes are different and we can move on. Number H. Again, I'm going to clear the fraction by multiplying by 10. So I'll end up with y minus 2x equals 5, where we add 2x to both sides, and that leaves us with y equals 2x plus 5. That's good. Letter I already has y isolated, but it has my variable and constant at the end, or coefficient at the end, so we're going to switch the order. Y equals 2x plus 5, so that's good. Remember, our commutative property of addition is what allows us to rearrange the order of those two without it impacting the solution to the problem. And then finally, J, we want to isolate for the variable y, so we're going to subtract 8x. 4y is equal to negative 8x plus 20. Should be already able to tell that we're going to end up with a negative slope, because when I divide by a positive number, that's going to remain negative, but let's go ahead and finish it. So 4 over 4 simplifies, and we're left with y equals negative 8 divided by 4, which is negative 2x plus 5, and that does not match.